seasoned indulgers of the astronomy hobby, this may be obvious, but those not as familiar with the field may not be aware that there are planets beyond our solar system. Many of them, actually. These planets that exist outside of our solar system are known as exoplanets. As of March 2020, over 4,300 exoplanets have been discovered, some of which may look familiar to the ones we find in our own cosmic backyard. But despite such similarities, many of these planets are vastly different from the ones we know. The first of these planets, discovered around a star like our own, belongs to a category of planet known as hot Jupiters. These are planets similar to Jupiter, with the main difference being how closely they sit to their star. There are too many of them known, over 300 in fact, to go over all of them, so I'll be comparing just one of these hot Jupiters to their namesake, Jupiter. The exoplanet in question that I'll be comparing to Jupiter is WASP-19b. But before I get into details about this exoplanet, I'll start with Jupiter's characteristics to establish a point of comparison. Jupiter is a gas giant. Gas giants are a category of planet that are mainly comprised of helium and hydrogen, much like stars. Jupiter is by far the largest planet in our solar system. If it were possible to wrangle them all in there, all of the other planets could fit inside of it. Jupiter is about 5.2 astronomical units from the Sun. An astronomical unit is a unit of measurement used in astronomy that equals the distance between Earth and the Sun. Therefore, Jupiter is a bit over 5 times farther from the Sun than Earth is. Due to its great distance from the Sun, it's a very cold world, with an average temperature of minus 162 degrees Fahrenheit. Also, because of the great distance between it and the Sun, it takes Jupiter 12 Earth years to complete a single orbit around our star. In contrast to Jupiter's long year, its day only lasts just under 10 Earth hours. In fact, Jupiter's rotation speed is faster than any other planet in our solar system. The second fastest is Saturn, our solar system's other resident gas giant, completing a day in a little under 11 Earth hours. WASP-19b is also a gas giant. It even orbits a yellow star like our Sun, and has a similar mass to Jupiter. That's about where the similarities end, however. WASP-19b is significantly larger than Jupiter, and unlike Jupiter, this planet is scorching hot, having an average temperature of 3,278 degrees Fahrenheit. The main reason for this, and many other differences between our gas giant Jupiter and this exoplanet, is WASP-19b is much closer to its parent star than Jupiter is to our Sun. In fact, it sits even closer to its parent star than the Earth does. Much closer. The space between WASP-19b and its star is only about 1/100th of the distance Earth sits from our Sun. Because it sits so closely to its star, WASP-19b doesn't rotate. The closer two objects are to each other, the stronger their gravitational forces interact. In this case, WASP-19b's gravity and the gravity of its parent star interact so strongly that the planet has now ceased rotating entirely. Only one side of the planet ever faces its star now. Also, due to the extremely close proximity to its star, WASP-19b's orbit is very short. It takes less than an Earth day, just under 19 hours. So it is clear that Jupiter and WASP-19b differ immensely from one another, to the point of being near total opposites. Beyond being kept in its orbit, Jupiter is too far away from the Sun to be affected much. Jupiter is cold. Day and night on this planet cycle rapidly without excessive gravity to slow it, and a single year on Jupiter stretches on for over a decade. WASP-19b, however, is so close to its parent star that said star has affected it drastically. WASP-19b is scorching hot with a year that lasts less than a day, and the overwhelming gravitational forces near its star have caused it to no longer possess a day and night cycle. Despite all of this, these two planets do have a few notable similarities. They are both gas giants with similar masses that orbit the same type of star. Under other circumstances, these two planets could have been twins. But these two planetary giants have followed very different paths, and it shows in the states they're in today.